Hi, I'm Cheryl Leach. In this problem, we're going to be using the second derivative test to help us find relative minimums and maximums. Well, what does the second derivative test tell us? Well, in the second derivative test, we're going to be looking at when the first derivative at a given point is equal to 0. That means we have a horizontal tangent. Then we want to examine what happens to the second derivative. And in this first picture that I have drawn, the second derivative is greater than 0. In other words, it's concave up. And it turns out that if we have a horizontal tangent and it's concave up, the only way that can happen is if we have a relative minimum. On the other hand, what if we again have a horizontal tangent, but this time our second derivative at that point is negative, which means our graph is concave down. If we have a horizontal tangent and it's concave down, the only way that can happen is if we have a relative maximum. This gives us a nice, quick, easy way to find relative minimums and maximums, but you have to be careful. It doesn't always work. One thing is that it doesn't help when we have a minimum or maximum because our derivative is undefined, for instance, at a cusp. And the other place you have to be careful of is what happens if the second derivative equals 0. We know what happens if it's greater than 0 or less than 0, but what if it actually equals 0? In this case, the test fails. You don't know what happens. It could be a relative minimum, relative maximum, or maybe neither. So let's go ahead and take a look at a particular example. I have the function f of x equals x to the fourth minus 4x cubed plus 2. I'd like to find the relative minimums and maximums, and I'm going to try to use the second derivative test. So the first thing we need to do is find out when those first derivatives are equal to 0. So the first derivative is 4x cubed minus 12x squared. We'll set this equal to 0 and then solve for x. Notice that I can factor a 4x squared out of both terms, and I'm left with x minus 3. Two things multiplied together that equal 0 means that one of them needs to be 0. So either 4x squared is 0 or x minus 3 is 0. And in this case, x squared is 0, and so x is 0. And in my second situation, x is going to equal 3. So there are two times when the first derivative is going to equal 0. Now we have to look at the concavity. So to look at the concavity, we need the second derivative. So let's go ahead and calculate the second derivative. My second derivative is going to be 12x squared minus 24x. So now let's see what happens at 0 and at 3. The second derivative at 0 is going to be 0. Well, now wait a minute. That means my test fails. I'm going to hold on to that for a minute, and I'll come back to it. Let's go ahead and take a look at what happens when x equals 3. So I'm going to have 12 times 3 squared minus 24 times 3. Okay. Now this is definitely going to be a positive number, because I have 12 times 9 minus 72, or 108 minus 72, which is, again, is definitely a positive number, which means my graph is concave up. And if it's concave up and the slope of the tangent line is 0, we must be talking about a relative minimum at x equals 3. So let's go back to the case where my second derivative test failed. When this happens, we can always go back to the first derivative test. So we'll come back to our first derivative and make our number line, marking down all of the critical numbers. I want to make sure that I include that 3, because when I'm doing test points, I don't want to choose anything larger than 3. I'm just interested in what's happening at 0. So pick any number that you like less than 0. For instance, a -1. And let's plug it into the first derivative. If I do that, I'm going to end up with a -4 minus 12, which is a negative number. Now I'm going to choose something between 0 and 3. Let's try a 1. When I plug a 1 into the first derivative, I get 4 minus 12, which is also a negative number. Notice that there was no change from increasing to decreasing. It was strictly decreasing the whole way through, which means that there was no relative extrema occurring when x equaled 0. Our only relative minimum was when x equaled 3. I hope this helps. Thanks.